May 5th, 1961, Freedom 7. The United States took the first small step on its journey to the moon. America's first man in space, Alan Shepard, rode the Mercury capsule. Lifted to 116 miles by the Redstone rocket's 78,000 pounds of thrust. 10 years later, the launch vehicle is Saturn V, with a thrust of 7.5 million pounds. On January 31st, 1971, the crew of Apollo 14 would leave Earth on their mission to the moon. The man who began our first decade of manned spaceflight would command the mission that would close that decade. Alan Shepard. With him, Stuart Roosa, who would orbit the moon alone while Shepard and Edgar Mitchell explored its surface. Their destination, a rugged area of lunar highlands called Fra Mauro. Apollo 13, aborted as it neared the moon, had been unable to land at this site. Now, we were trying again. But why Fra Mauro?
What happened to the moon during its first billion years, a period erased on Earth? How do the Earth and moon differ in overall composition? By visiting Fra Mauro, we hope to sample the very bedrock of the moon, material very different from that so far collected, material perhaps dating back to the beginning of the solar system.
How can you think of the soil being 4.5 billion years old when the igneous rocks which presumably underlie it are only 3.5 or 3.7 billion years old?
This, I suppose, will be dramatically refuted or confirmed at the Apollo 14 mission when they actually visit Fra Mauro.
Most of the activity is associated with one place on the moon, and we have tentatively located that place in or near the crater Fra Mauro.
Everything went smoothly during Earth orbit and for the burn that sent Apollo 14 toward the moon. Then Stuart Roosa moved the command module Kitty Hawk to a docking with the lunar module Antares, still attached to the third stage of the booster.
And we docked. We're unable to get a capture.
Twice they tried. 3 times.
Okay, Houston, I hit it pretty good and held 4 seconds on contact, and we did not latch.
Roger. We're seeing it all on TV here.
Well, we better back off here and think about this one, Houston.
As the astronauts waited, an identical docking probe was brought into mission control. This probe on the command module fits into a funnel-like device on the lunar module called the drogue. Tiny catches on the probe's point engaged the drogue. It was these capture latches that were not holding. In space, the astronauts tried a 4th time. And a 5th.
No latch. No latch, Houston.
Roger.
In space, on Earth, they searched for a solution. Then, on the 6th try...
I believe we got a hard dock, Houston.
As they coasted to the moon, the crew brought the probe inside the spacecraft for examination. On Earth, the probe was tested and retested, for we had to be sure that the probe would work for the most critical docking, as Shepard and Mitchell returned from the lunar surface. On February 4th, Apollo 14 went into orbit around the moon.
This is really a wild place up here.
As Apollo 14 was on its first orbit, the third stage of the booster smashed into the moon at its planned target point. Its impact picked up by the seismometer left by Apollo 12. The structure of the moon's interior is one of the major mysteries of lunar science. Now another piece was added that could help solve the puzzle. Later that day, Shepard and Mitchell climbed into the lunar module Antares and undocked prior to descent.
And we're free.
Beautiful.
Very good.
But as they checked out the lunar module, a problem appeared. An erroneous abort was being signaled on board Antares and in mission control. Should this occur during the landing burn, Antares would abort automatically, and the landing would be off. The mission control team had 2 hours, the time of one lunar orbit, to find a solution. Flight controller Dick Thorson diagnosed the trouble as a loose particle in the abort button. The burden then came to rest on the shoulders of computer programmer Donald Iles. Working against time at MIT in Cambridge, Massachusetts, he reprogrammed the lunar module computer to ignore the false signal. This new program was then checked out in a simulator at Cape Kennedy. As Antares came into contact with Earth again, the instructions were sent up to the crew.
Antares, Houston, the computer's yours.
Thank you. You troops did a nice job down there.
That was beautiful.
Less than 10 miles above the lunar surface, Shepard and Mitchell swept across the landing site.
And Antares, Houston, your go for Mauro.
It's a beautiful day to land at Mauro.
Then, another problem. The landing radar, which would tell them their altitude above the lunar surface.
On radar. On radar.
Antares, Houston, would like you to cycle the landing radar breaker.
Okay, cycle.
Okay, I would like to accept the radar.
Bridging through. Great. Great. Oh, that was close.
Okay, and monitor descent fuel.
I'm starting the camera.
10 seconds to go.
Okay, there's pitch over.
Right on
and there it is.
Right on the money.
Right on the money.
That's beautiful.
Right out the window, just like it should be.
Antares, Houston, your go for landing.
Cone Crater, a major objective of this mission to Mauro. A hole blasted in the moon's surface eons ago that could provide a scientific clue to the history of the moon, the Earth, and the solar system.
Right on schedule. Right on schedule now. Went by Cone Crater right outside to my right.
We think that the Fra Mauro area was formed from material thrown out by the impact that created the Imbrian Basin to the north. If this is the case, we could get samples torn out from as deep as 60 miles in the lunar crust. All in all, the Fra Mauro material should contain a great deal of new information about the early history of the moon, and thus help us to better understand the formation of our own Earth.
Okay. Okay, I'd give it a few clicks. You're through 200 feet. 5 feet per second. That looks good.
No level here.
9% fuel looks great. Okay, looks like you're going right over the middle of triplet. You're 170 feet out, 2 feet per second down, 8% fuel. You're looking good. Okay, you can move on forward. You're just barely crossing North Triplet. Barely crossing North Triplet. You can land over here. There's some dust, Al. You're on your own.
Starting down. Starting down.
Okay. There's good dust. Crossing down. Looking great.
60 seconds.
40 feet. 3 feet per second. 30. 3 feet per second. Looking great. 20 feet. 10. 3 feet per second. Contact now.
New stop. Auto.
We're on the surface.
Okay, we made a good landing.
Roger, Antares.
5.5 hours later, Shepard left the lunar module to begin the first of 2 explorations.
Cutting down the ladder. Roger.
10 years later, 114 hours, 22 minutes after leaving Earth, Alan Shepard stepped onto the moon.
It looks like you're about on the bottom step and on the surface. Not bad for an old man. Okay, you're right. Alan's on the surface, and it's been a long way, but we're here.
4 minutes later, he was joined by Ed Mitchell.
The last one is a long one.
Following the tradition of 2 previous missions, Shepard and Mitchell planted the flag in the lunar soil.
How's this, Bruce? Look okay?
Roger, that's a good sight.
The next job was to load the Met, a rickshaw-like wagon the astronauts would use to transport their tools of exploration and collected samples.
One of the big factors in lunar exploration is mobility. In Apollo 14, we had the Met, which let us move further afield than the previous 2 missions. In future missions, we'll use the Lunar Rover, a sort of moon-going dune buggy. This mobility will mean less time spent in getting from here to there and more time collecting scientific data.
Okay, I'm going to stop here and rest for a minute now. This damn thing's heavier than I expected.
Shepard pulled the Met while Mitchell carried the barbell-shaped package containing an automatic scientific station they would assemble. A station designed to continue broadcasting data to Earth for a year after men departed from Mauro.
Okay, Houston, we're proceeding over a very fine-grained regolith we described before. The heavens, that's a deep hole. Going down in a depression. Deep, very deep depression. That is what it looked like. Roger, you're visible from about the armpits up right now. Nothing like being up to your armpits in lunar dust.
Finding a suitable site to place the scientific instruments was the next order of business. Shepard and Mitchell now began setting up the automated scientific laboratory. A small nuclear generator to power the array. The central station to transmit data to Earth. A seismometer to detect and measure activity on and within the moon. A series of 3 experiments to measure charged particles near the lunar surface. An independent experiment to reflect laser beams from Earth, enabling extremely precise measurements of such things as Earth-to-moon distance, the wobble of the Earth's axis, continental drift, and shifts of the Earth's crust. And a mortar to be fired by a signal from Earth sometime within the next year. The impact of its charges would be picked up by Apollo 14's seismometer. As a final exercise, Mitchell used the thumper, a device to explode a series of controlled shotgun-like charges. The vibrations from these detonations were picked up by a series of instruments he had previously deployed. With the instruments set up and operating, they headed back toward Antares, pausing on the way to collect samples.